Hello, welcome back. Today let's try to solve another Leetcode problem. 2765, longest alternating subarray. So we are giving array nums. So inside of the nums, we just needed to return the maximum length of the alternating subarray. What do I mean by subarray? Subarray is a continuous non-empty sequence. For example, this is 3, 4, and 3, 4 are subarrays. And that also meets the condition of alternating subarray. So for the alternating subarray, it means the first number, when you start with the first number, it is S0. So S1 should equal to S0 plus 1. It means this number 4 should be equal to 3 plus 1. So you need to start with always the smaller number, and then you're going to alternate it like this, 3, 4, and 3, 4. So this is what the question asked. If you didn't find this, you're just going to return a -1. This is what I did in the contest. And this is not a good method. So for this one, I used the ON square time. Yeah, because for me, for the first loop, I used I to check one by one, and then if result I equal to 1. So here for the result, I just use a difference of the array, nums I minus 1 for I in range 1 to the length of the nums. So for this one, inside it will be 1 and -1, if I remember right. Yeah, it should be 1 and -1. So I only need to check the conditions for once. It means it will be started with 3, 4, and 3, 4 like that. And my answer will be updated by check of the result starting from the I. So this is the array. So inside of this array is my check function. The check function is exactly like what it said here. It will be alternating like this. So this is why it is the ON square time. It's not, yeah, let's just submit it. It can pass because for the Leetcode, it designed for this problem, you can use ON square, or you can use ON cubic to pass. Yeah, you can see that it is like 49% of all Python 3 submissions. But today I'm going to talk about another method. It is much better, and it is also a template. So I call it list groups template. Now let me make a comment of this code. Yeah, because for this kind of code, basically it's not a template. You just do it according to the descriptions. Now I'm going to do it like a template. It is much harder for that because you just use the ON and time complexity to solve it. And there are a lot of edge cases you need to consider. That is why if they designed for this problem maybe nums.less equals to 10 to the power of 5, and then it would be a medium problem. Or, yeah, it would be a medium problem, I think. It cannot be a hard problem. Yeah. Now let's try to do it using the list groups method. So for me, for my template, I will use the result and I and n. So the result will be -1 if I didn't find it. So this is a -1. If no such subarray exists, so it will be -1. And for iPotter, it will be 0, and n will be length of the nums. Now I'm going to use a while loop. So for the while loop, here will be a little bit different. Here the I will be less than n minus 1. Normally for my template, if it is a normal list groups problem, I always use I less than n. But here, we need to find the starting point. So for example, this, for example, we find this 3, 4, 3, 4, it is the longest. And we can also find like 2, 3, it also works. Yeah, but it's not the longest. But when we start with 4, 3, it's not okay. So this is why we need to find the starting point first. If I want to find the starting point, I need to let the I less than n minus 1. Yeah, because I will use this formula here, s1 equals to s0 plus 1. So I need to check. So let me check. So while this I less than n minus 1. Let's check the I pointer first. Yeah, let's check this condition first. So basically, I'm going to check the first number. If I find with a 3, 4, like 3, 4, I will continue for checking the maximum length. If I find a start with 4 and 3, I will not check like that. So if nums I if nums I, yeah, let's just use this formula. If nums I plus 1 not equal to nums I plus 1. So this is a here. So here we are checking equal. If they are not equal, we just update the I by 1 and continue. After that, if it is something like 3, 4, 3, 4 or 2, 3, like that, yeah, now we can update using the template with a start pointer equal to I and while I less than n minus 1. Yeah, we need also to check the conditions like here, if they are alternating or not. So for checking the alternating, we need to check if this nums I plus 1. So I plus 1 means this start equals to I. So I plus 1, it means the next number of the start. So if I plus 1 equal to nums start should also plus, because we need to check the alternating. It means, for example, if we are starting with 3, if it is the first number after that, it is 4, so this is I plus 1. If this is 4, it should be the nums start plus 1. Yeah. So for this one, if it is 4, how should we check it? We can use let me put I minus start plus 1 modular 2. Yeah, because if it is the next point, if it is I is the same point, for example, if I equals to the start, it means it is 1 I equals to start minus start plus 1, so it is 1 modular 2, it is 1. So it means if I is the starting point, it is 3, and I plus 1 is 4. So this means 3 this means 4 I plus 1 nums I plus 1 equals to 3 plus 1. So if it is the next number, for example, it is 3, so here the I minus start plus 1 should equal to 2. If it is equal to 2, 2 modular by 2, it is 0. So it should equal to this start. It is 3 equals to 3. So this is the tricks for solving the problem of alternating. Actually, it is the same like my code here, but this is more clear. But here, maybe you need to put them in one line of code. You need to check the conditions. Now, if everything is okay, the I should update it by 1. After that, we can get our result should be the maximum of result with I minus start plus 1. Here is the same, just checking the length of the alternating string like that. And we should take care of that, because normally for the template, the I should be updated by 1. But for this problem, we don't need to do that. So this is why if you are using ON and you just use ON time complexity, it should be a medium problem, because this is also a hard part. For example, 2, 3, and 3, 4, there is overlap for this number 3. This means you cannot update if you after you checking with 2, 3, you will go to 4. You cannot check like that. After you are checking 2, 3, you have to go back to 3, 4, 3, 4, and there's only one number you need to go back. So this is why you don't need to update the pointer I plus 1. You don't need to do that because you have to go back. After 2 and 3, you have to go back, check 3 and 4. And there's only one number you need to go back. Now let me return the result. Yeah, let me run it to check if this method works. As you can see, it works. Now let me submit it to check if it is faster than before. As you can see, it's much faster, nearly 100%, because it is just ON time complexity. Let me explain a little bit about this line of code, why we don't need to update the I. Yeah. Let me give you an example. Like, for example, we have 3, 4, 3, 4. Yeah, now we have 4, 5, 4, 5, 4, 5, like that. So you need to check the length, like 3, 4, 3, 4, it is okay. For the next step, if you're gonna check 5, 4, check from here, you're gonna check 5, 4 with 5, 4, it is not okay. You have to start from this number 4. So this is why the I should not be updated. Yeah, because basically in this loop, it will update all the I. You have to go back. This means I will not be updated by +1. So this means you have to go back just one place that is okay. Go back to 4, and then we get our result 4, 5, 4, 5, and 4, 5. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like that.